Okay, this is a continuation video um, under advanced calculus on implicit functions. The question reads, if x equals x power 3, y power 2 plus 3y, find dy dx. So here we go. There was a formula that was to be used. So the formula was dy dx equals negative partial derivative of f with respect to x partial derivative of f with respect to y. Then I said if we have this one, it means we differentiate the function considering x. So differentiate the function considering x. Likewise, this one now means differentiate the function considering y. So differentiate the function considering y. So that is for that case. So now we will need a function which is going to contain both x and y. So this is why we say let f of xy be equal to the equation. So that is our case there. Next, let this part become come to this part. So this means we're going to have then this part will move cross the equal sign to become negative, and this part will also move become negative, and then where they were you have a 0. From there ignore the 0 and you're going to have this function. So this is now our function. From there now we can now differentiate this function considering x to get this one, and then we can differentiate the same function considering y. So that is the case. So let's consider x. So we are just differentiating where there is x. If there is no x, the answer is 0. So here we are. We differentiate x, it will give us 1 minus. Differentiating the x part will mean x, the 3 will drop and then will remain like that. On this part, there is no x, so the answer is 0, meaning partial derivative of f with respect to x is giving us this value. We now go to partial derivative of f with respect to y. So in the same case, we are considering y. When the part has got no y, then we are going to say the answer is 0 there. We are using this function. At this point, there is no y, so our derivative is 0. We come at this point, the y is there, so this 2 will drop to the front. So it will be 2x power 3, y will remove 1. So we just remain with power 1. Then on this part, there is y negative 3y. So whenever the number and the letter are attached and the letter is having power 1 and it is the letter you're differentiating, you just get the number as the answer. So in that case, we'll just get 3. So simplifying this one, it now gives us, we ignore the 0, we have negative 2x power 3 y minus 3. So that is our case. So this is the work. We now use this formula here, which is dy dx equals negative partial derivative of f with respect to x divided by partial derivative of f with respect to y. So our dy dx is now negative, like that. Then we do the replacement. The negative stands, we replace the x part, divided by the part for y, which is just here. So we can see that there's negative here and there's negative there. In the meantime, I'll replace as they appear, but we can do something there. So now, seeing the negative on both parts, we can factorize it. So the top part has got a negative, which is coming in from the formula here. So this is the negative which we have. The bottom part, we can factorize the negative as well. So meaning this guy now becomes a positive, and this guy becomes a positive also. Meaning the negative on top and below, they'll cancel each other or divide off each other. Meaning the top now remains without this negative, but just what is in the brackets. And the bottom part, we eliminate the negative. So this gives us our final answer to this question. So this gives us our final answer to this question. Hopefully it was clear. Thank you.